All right, section 9.3, sequences. One of the most natural ways to study patterns in math is to look at an ordered progression of numbers, and that's called a sequence. I think that's something you all are familiar with, a sequence or a pattern. Okay. So I have some examples here of some sequences. As you can see, A is 5, 10, 15, 20, 25. B, 2, 4, 8, 16, da 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 da. 2 to the k power is the pattern, and it keeps going, dot, 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 dot. C, 1 over k, where k would be 1, 2, 3, 4, and on and on and on and on. And D is like a pattern of A1, A2, A3, A4, and then some infinite number of a k. All right, so these are all sequences. The first one is what we call a finite sequence. Okay, finite has an ending, and then these last three are called infinite. We will use that, definitely those words, finite and infinite again, so wanted to make sure we were clear about what a finite is and an infinite. I'll notice on the last two, so on these two right here, we were able to give a rule. So they have like some kind of rule that defines we call it usually the nth number. In this case, it's got a k, so the kth, I don't know how to say that, term of the sequence. Like I said, you'll hear it as nth sometimes too, but this letter here was k instead of n, so the kth term of the general infinite sequence. Okay, so let's talk a little bit more about different types of sequences. This is defining a sequence explicitly. You're going to see that again is writing an explicit formula, and then the next one we're going to have is a recursive. So explicit. Okay, so this is how, anyways, here's an equation or an example. Find the first 6 terms and the 100th term in the sequence AK, in which AK equals k squared minus 1. Okay, so because we know the kth, I don't know, which day we use in, kth term is explicit, we only need the number to evaluate the term. So right here defines AK. So if we say A1, which is the first term, then we know that K equals 1 here. All right. If we have A2, then we know K equals 2. This is the second term. So this is the first term, second term, third term, so on and so forth. Okay. So I'm just trying to explain to you where we're going to get these numbers from. Okay. So, all right, so if I want to do A1, so I'm going to use this equation right here. So AK, I'm going to write I like to write underneath it so you can kind of see where all the numbers come from. So if I do A1, well, what is K here? K here is 1, so it's going to be 1 squared minus 1, which is 0. Then A2, so what is K here? It is 2, so 2 squared minus 1, so that's 4 minus 1, which is 3. A3, which is 3 squared minus 1, so that would be 8. A4, again, K is 4, so 4 squared minus 1, it's going to be 15. I'm going to have to squeeze it in here. A5, so 5 squared minus 1 equals, let's see, 25 minus 1, so 24. And then the 6th term, because it told us to find the first 6 terms, would be 35. So here would be the first 6 terms of your sequence. Then the second part of this is to find the 100th term. So we note that as A100. And that would be 100 squared minus 1, which would be 9. I'm going to put it on the next line because it's not going to fit. 9,999. So that would be the 100th term. Okay. Now, explicit formulas are the easiest to work with because you're literally just plugging in like the first term, the second term, the third term, the fourth term, fifth term. But there's another way. It's called recursive. So that on recursive, they tell you the first term, and then you relate it to the previous terms. Okay, so this is recursive. So recursive is relating a formula to the previous terms. Okay, so explicit, I kind of feel like it's just like it is what it is. You just plug in 1, 2, 3, whatever term you're looking for. Recursive is going to relate the previous terms, and I'll show you what I mean. So find the first 6 terms and the 100th term. For the sequence, defined recursively by the conditions B1 equals 3, and then here's the formula that they want you to use. And then they want you, this means they want n to be greater than 1, so you have to start at n2, okay, because we already know B1, by the way. So I'm going to make a list over here, and I'm going to show you. We're going to do B1, B2, B3, B4, B5, B6. We want to find the first 6 terms. Okay, sorry. Okay, so if you look at B1, B1 is 3, right? So if I want to find B2, I'm going to write it over here so I have a little space. So I'm going to write this equation right here. I'm going to show you how this works. These are subscripts. This is like a little subscript down here, so don't be confused by my handwriting. So if I want to find B2, let's relate again. What is n here? N is 2, so I'm going to do 2 minus 1. Okay, and B2 equals, what's 2 minus 1? Let's all say it together. B1 plus 2. So this formula, B2, is B1, which is, we already told us, they had to tell us what the first term is. B2 is 3 plus 2, so that's going to be 5. Okay. Okay, let's back that up. Okay, this is 5. I erased it. So let's go to B3. What is n now? It's 3. So 3 minus 1 plus 2. So B3 equals 3 minus 1 is B2. Well, I just found that. So B3 equals 5 plus 2. So essentially, I'm using the last one I did. That's why it's called recursive, because you use the number that you got relating a formula to previous terms. So that was the previous term. Okay? And so I'm guessing you could probably see the pattern here. What are we doing every time? We're adding 2. Okay, so this is going to be 9, this is going to be 11, and this is going to be 13. Okay, so then it says find, I'm going to erase this for a second so I get some room. Find the 100th term. Well, you could go through, I suppose, and do all of those. It takes a while. Or you can realize what we're doing here. We're adding 2 every time, right? So this would be, let's relate these two. So this would be 3 plus 1 times 2, which would be 5. And the next one would be 3 plus 2 times 2, which would be 7. Okay, and this one would be 3 plus, 3 times 2. So 6 plus 3 is 9. Do you see how I'm relating these? This number is like the n minus 1. So this was, So let me show you. So 3, what are we looking for the next one? We're looking for the 5th term, but instead of, so we're going to say like n minus 1 times 2. So n minus 1, the 5th term, so that'd be 5 minus 1. So 3 plus 4 times 2 equals 8 plus 3, that equals 11, and that's what we have. So if we want to find the 100th term, we're going to do the first term, so 3, plus the n minus 1 times 2. So 3 plus 100 minus 1 times 2. So 3 plus 99 times 2, which is going to be 201. Okay, and that's how you find the 100th term. Now, I'm going to tell you, this is going to lead us to an equation right here. You will be using this equation coming up here in a minute to find the nth term. Okay, so when it's not as straightforward as you just plug in the term number, then you are going to use the formula to find the nth term, which is what we're about to do. And this is kind of the way to lead you there because they're proving that this formula actually works, and it does. Okay? All right. So 2 sequences that dominate the math sequence world, I guess, I don't know. Mathematic applications, I should say, are arithmetic. I spelled that wrong. I'm gonna let's try that again. Arithmetic. Okay, arithmetic and geometric sequences. All right. So arithmetic, we're going to talk about a common difference. So arithmetic sequence, you either add, I'm going to write this down, add or subtract a constant number to get the next term. Okay? So you're either going to add or subtract the constant term to get the next number. It has to be constant. You can't be adding 2 and then adding 3. It has to be I'm adding 2 every time, or I'm subtracting something every time. Okay, and so the abbreviation for the common difference is going to be D. And the way we find D is we do the second term minus the first term. And then, or the third term minus the second term, or the fourth term minus the third term. You get the point, is it has to be a constant difference. Okay, so in this case we have 1 minus 5, that equals negative 4. Okay, if we want to check, we do negative 3 minus 1, that equals negative 4. Okay, what about negative 7 minus negative 3? That equals negative 4. So we have a constant difference. So here the D is negative 4. Okay, that's arithmetic. It's like arithmetic, but they say arithmetic. But think about adding or subtracting. Okay, the other one is geometric. So what are the other operations besides adding and subtracting? Here you would multiply or divide a constant. So again, it has to be the same number every time. It can't be we're multiplying by 2 here, we're multiplying by 10 here. It has to be we're multiplying by a certain number or we're dividing by a certain number. Now I will say divide is used loosely. I'll show you in just a minute. I'll do one in just a second. Okay, so let's say I do this one. So, common ratio. The letter used is R. So remember we use D up here. This is R. Okay, and it is the second term divided by the first term, or the third term divided by the second term, or the fourth. You get the point. It has to be the same for all of these. Okay, so in this case, let's see. If we want to find the R, we would do 3 divided by 1. That gives you 3. Or 9 divided by 3, that gives you 3. Or 27 divided by 9 is 3. Or 81 divided by 27 is 3. So our R is 3. Okay. Now, what I was going to say before is when you divide, I don't have an example in front of me, but we'll just see if I can make up one. So if I do like, if I do something like this, so we're going to do 2 over 4 to find our ratio, so that would be 1/2. Or 1 over 2, or 1/2 over 1. So our common ratio is 1/2 on this sequence I just made up real quick. This would be dividing by 2 or multiplying by 1/2. Typically, you won't say dividing by 2. You write 1/2 because that's how you say divide by 2. So we're multiplying 4 times 1/2 and we're getting 2. So I want to be loose on divide. It's really multiplication every time because when you divide, you multiply by 1/2. So you can't put in the computer, I divided by 2. You have to put 1/2. Okay, so now let's get into the equations. On this section, we're going to talk about the equations for finding the nth term. Okay, on the previous page, they used K. The nth is much better. I don't even know why they started with K, but anyways, the nth term. So for arithmetic, okay, so this is the recursive. Sorry, I couldn't find the recursive formula would be a n minus 1 plus your common difference. Okay, and then for explicit, it's going to be an equals a1 plus n minus 1 times d. Now remember, we used that on that last problem we did on the example before. Okay. All right. Geometric. So you might want to write these equations down because they're going to ask you to find formulas recursively and explicitly. Okay. So let's write down geometric real quick. Remember, instead of a D stands for common difference. And now we're going to use an R on geometric. Okay, so geometric, so recursive. Now they're going to ask you to find these recursive and explicit, so we need to remember these. So recursive is going to be an minus 1 times R. Okay, and then explicit, they're not real good about sharing this information, so I'm trying to decipher here. The explicit rule is going to be a1 times r n minus 1. Okay, so if you've done this before, which you might have done in Algebra 2, I know I do it in Algebra 2, typically these were the equations you used a lot. This pre-cal book is throwing in these a little bit, but it's okay. We can conquer it. Okay, so write these down. You're going to need to have them with you. Take a picture, do something. Okay, so we're going to do 2 examples real quick on this, and then we'll be done. All right, so for the following sequence, find the common difference, the 10th term, a recursive rule, that's where we're going to use the equation, an explicit rule for the nth term. Okay, so here's my sequence right here, in case it's hidden. Okay, we need to find the common difference. Okay, remember the D, and we can do the second term minus the first term. I'm probably going to check myself because it needs to be consistent, so I'm going to do more than 1 probably. So we've got -2 minus -6, so that's going to give me -2 plus 6, which is 4. Okay, I'm going to go ahead and check. So I've got 2 minus -2, so it gives me 2 plus 2, which is 4. So it looks like my common difference is 4. So that's A. All right, easy. All right, so let's do B now. So this was A. B says find the 10th term. So I'm going to use this rule right here. Okay, because we know the first term. We know the number we're trying to find. We're trying to find the 10th term. And then we know the D. So the 10th term, it's going to be A1. So this is A1. This is your first term. So negative 6 plus, we're trying to find the 10th term, n. This is n. I'm going to erase this. So this is really the equation n that I would always use to find the nth term. Okay, so negative 6, so n is 10, so 10 minus 1, and we found our difference was 4. Okay, so I have negative 6 plus 9 times 4, and that's going to give me 30. That's 36 minus 2. So that's the answer for the 10th term. Okay. C is write a recursive rule. Okay, so I'm going to go back and look at which one's recursive. It's this one right here. So we're going to do a n equals a n minus 1 plus 4. That's your answer right there. Now, you might have to write, I honestly can't remember when I looked at the problems if you have to write this or not, but you have to make sure that you start after 1. So usually they'll put n is greater than 1 or n is greater than or equal to 2. I don't know if you have to include that, but if you do, that's true all the time. So this is all the time. All right, so then we're looking for explicit rule. Okay, if you go back up, this is explicit. Okay, so we have a n equals a1. Now we kind of already did this up here, but we're going to leave the n in because we want to find the nth term. So a1 is negative 6, n minus 1, and then d is 4. So we're going to go ahead and do the math. We distribute this out, so negative 6 plus 4n minus 4. And so that would give me 4n minus 10. That would be my explicit rule. Okay? Remember, we talked about at the very beginning, explicit means you're going to plug in, so it doesn't matter, like if you look at this equation, I'm going to point to it with my arrow so you know what I'm talking about. If you look at this equation, you can do the 10th term by just plugging in 10 for n. So 4 times 10 is 40, minus 10 gives us 30, and that's what we found for the answer. So it's very straightforward. It's whatever the nth term is. Now remember, recursive uses the previous term. So that's why it has this n minus 1 here. So it's using the third term to find the fourth term, the fifth term to find the sixth term, and so on, so forth. So remember what recursive and explicit meant. Okay, now let's do geometric. So we're going to do all the same things with geometric. So here is my equation. I think you could probably already tell what the common ratio is. I did this one, but I do want to make you aware of the fact that, like, let's just make this negative right here. You would have to indicate if it's positive or negative. So here we know the ratio is 2 because 6 divided by 3, 12 divided by 6, 24 divided by 2, they're all going to be 2. Now if I added in these negative signs, it would have to be negative 2. And you do need to make note of that. This problem does not have the negative sign, so I don't want to mess up what I already have going on. But I want to make sure on the difference and the ratio, they can be positive or negative. So make sure you note that in the formulas. Okay, so the common ratios, I'm erasing now. Common ratio is 2, so I did A. B, we find the 10th term. So we're going to use the AN equals A1 R n minus 1. Okay, so we know all this. So we want to find A10. So what's in here is 10. A1, we already know what A1 is. This is the first term. So 3. Our ratio is 2. And then n, remember this is n, 10 minus 1. So this is going to be 3 times 2 to the 9th power. I do my calculator. Remember to do exponents first, then multiplication. And it's going to give me 1536. Is going to be my answer. Okay, then we're going to go to C. This is going to be, not explicit. It's going to be recursive first. So this is a recursive. Remember, this is the one that uses the previous term to find it. So if you go back, I kind of told you the formula. Set it up for you right here. Okay, this is all you need to know. So recursive is going to be AN 2 AN minus 1. Okay, and remember we have to add in this. So for where n is greater than or equal to 2. And why we want 2 is because we already know a1. They have to give you a1 on recursive. So a1 here is 3. They would give it to you, and then you would have to start with the number 2. N1 is already taken. So you got to go greater than 1. You got to go to 2 and above. All right? And D would be explicit. So an. I'm going to write the formula down just because we probably going to use it the most, honestly. So this is going to be the 10th term. Oh, no, we're not finding the 10th term. We just found the 10th term. So we're going to find the nth term. So A1 is 3. We know R is 2, N minus 1. Now, before we like hippity-hoppity distributed property, then added like terms on the explicit one of the arithmetic, you can't do that here because it's an exponent. So you just have to leave this as your answer. So here's your answer here. So there are the 4 answers to those problems. Okay, so I think, I don't know if there's another type of problem. If there is, you guys can probably figure it out with sequences and series because you are super duper smart. But if there's something that you're struggling with, just let me know. Send me a screenshot. I usually try to work it out or give you a little hint, and it all works out. Okay? All right, talk to you later.